the chemistry IDU. You may find useful skills in this video for the physics and biology. You're going to have a data set where you've repeated an experiment, say approximately 3 times, and you have a range of temperatures which are repeated 3 times. What you need to do is you need to type it into a vertical list in Excel. I've typed the Y's on the right and the X's on the left. It doesn't really matter what order, but when you come to calculate formulas, this is quite important. Now, this is how you insert a graph. You need to select the data. You need to press Insert, Chart. And you need to change the chart type to scatter. This might already be automatic. You can see then we've got the temperature or the data on the right hand side on the y-axis, and then the x-axis as expected here. We have got 2 quartiles because we have both positive and negative temperatures. If this experiment's to do with temperatures, yours is going to be a bit different. Now, like for this graph, we need to make sure we are analysing it properly and making sure it's displayed properly. So these are the things we are going to change: the vertical axes, the horizontal axes, and the trend line. These numbers may need to be changed. So the first thing we're going to do is we're going to double click on the graph, and then we are going to go to Customize. We're going to press on the vertical axis, and we want to change what the vertical axis is going to look like. You will find this on the grid lines and ticks aspect of the menu. Now, changing the vertical axes is the number of lines we are going to have to cut the vertical axes, for example. So let's change this to 9. And you can see that here we've changed the number of spaces between 0 and 20, so we've got more specific values defined. Now let's change this to 19. Now I think this is the best because they've included 19 lines from 0 to 20, which means that this section of the graph will be split into 20 different sections. Now if we do the same for horizontal, we want to split these. Now we're going from 0 to 2, 2 to 4. There should be 2 jumps between 0 to 2 and then 2 jumps to 2 to 4. So we want to include 1 additional line to represent how we get from 0 to 2, because we need 0, 1, 2, 3, 4. So change this to 1 line, and you can see now we've got a line which represents 1. Last but not least, we would like to add a trend line. So we're going to double click on this again, and we're going to look through each of these menus here, and on the series menu we can find trend line, and we can add an equation, use equation, and we can even show Pearson's, which is there r squared. So it says 5.01 times x, but it's actually minus 5.01 times x plus 46.9. So our equation would be y equals minus 5.01 x plus 46.9, y equals mx plus c. And this represents our trend line. However, you can see that this doesn't quite follow a linear pattern, and the r value is quite low. We want that to be closer to 0.99. So therefore we need to change this graph and do something else with it. But this would be the first step of your IDU for chemistry. So the first thing we're going to analyse is the following. Let's have a look at the top table. Let's say if we were to analyse the data in column X and column Y, this is the graph we would get. And like the previous graph, what we would find for this is that it doesn't quite hold a linear relationship. This is quite difficult to see with a limited number of values, but you can see the trend line is going to be something like this. And because this is part of a smooth curve, and because I know my different graphs well, I know that this looks like it's part of a quadratic curve. It's the right-hand side from the minimum of a quadratic curve. So I'm going to guess that the relationship of this graph is something to do with a quadratic. So in order to see what the quadratic equation is going to be, you need to transform this table, and this is where we transform it here. Let me show you. What we're going to analyse instead is we're going to copy down the y values, and for your IDU you'll do the same, but instead of taking x to be y versus x, we are going to change this left-hand variable to x squared. So we're aiming for effectively this kind of equation. We would like a straight line where it's analysing y in terms of x squared, because x squared is going to be our new x variable, and hopefully we can generate a straight line. We can generate a straight line if the original relationship is indeed a quadratic. So I copy this, so I select it, Control C, go down here, Control V. Now in terms of generating x squared, you can do the following. You could say this value times by itself. So I put G11 times G11, times is a star, press enter, and then you can drag this down. Now, looking at this relationship here, we can see now that it's exactly a strong positive correlation, and we can even analyse Pearson for this. So if I was to analyse Pearson, what I would do is the following. I'd type in equals Pearson, and it says you've got to select data y first and then data x. So data y would be this column, and then I'm going to put a comma and then data x, and then I'm going to press enter. And Pearson is exactly 1. So this is a perfect positive correlation. But what we want to be able to do is to do the following. We have pasted the data into a spreadsheet. On the spreadsheet, we've created another table of values. We've then plotted a scatter diagram for x squared against y. Our table is different to this, so I'm going to just get rid of this here. Then the next step we've done is we've calculated Pearson. So we've done all these different steps, and last but not least, we want to calculate the slope and the intercept. So pause the screen now if you would like to pause it and find out more information about what we're talking about. So let's calculate the slope. Now when you do the slope, we want to analyse the slope of this particular data. Now if you're copying and pasting data and you want it to not change, you need to put dollar signs in front of it. So I put a dollar sign in front of the H, a dollar sign in front of the 20, a dollar sign in front of the H, a dollar sign in front of the 26. I'm going to carry on this process. So in the end, I add 8 dollar signs. This means that when I'm calculating the slope and the intercept, what we end up getting is we can copy the formula in the Pearson cell, which is cell F28, and paste it here, Control C, Control V, and then instead of doing Pearson, we're going to write slope. And you can see that it's still referring to the correct data set, even though we've moved one cell down, slope. There we go. And then we're going to copy and paste. And we're going to say we've got here intercept. You can see I've spelled intercept incorrectly, so make sure you spell it correctly. Excellent. Now, we can use these two bits of information to find out what our equation of our line is going to be. So we're going to have something like y equals m is going to be the gradient. The gradient is the slope. 1x squared, well, we've decided that our equation is to do with x squared, so it's going to be 1x squared plus, now the intercept is 1. So our overall equation is going to be y equals 1x squared plus 1. And the reason why we were able to discover that was because we decided that the original graph looked like a quadratic. We guessed, therefore, it's going to be linked to x squared. Luckily, it linked exactly to x squared because it's 1x squared, or just x squared on its own. We then analysed this on a graph, and because we were then able to transform it from a quadratic to a linear graph, this shows that this x squared relationship is true. The aim of your IDU is to transform your original graph into a straight line and show through Pearson that it's close to 1, because then that shows that this relationship x squared is true. But in your IDU, you will not have an x squared graph. You'll have some sort of different graph. This is the kind of graph you are going to be having. This graph here then is a little bit different. It might, to the untrained eye, look like a quadratic graph, but it looks more like the beginning of the coronavirus wave graph because it's exponential. Exponential just gets continuously steeper, whereas with the quadratic graph, it's going to be more of a gentle increase like that. It's not going to be quite so steep. That would be the general way I would think about that, although this is not technical language we're using. So what we're going to do with this then is the first thing we're given is our results for the experiment. Now, like before, I'd like you to put the x on the left and the y on the right. So a exponential graph is going to be a number to the power of x. So if we go on to Desmos and we take 2 to the power of x, that would give us an exponential graph. Similarly, we could have 2 to the power of minus x. Now that's going to be an exponential graph but representing a decay. So we want our graph to be somewhere of this format. So instead of taking x to the power of something, we're going to take a number and we're going to take that to the power of something. And we're going to take it to the power of x. So let's take the number 1.4. The first thing we're going to do is we are going to have a look at this, and we are going to take a, which is our chosen guessed value, and we're going to do a, which is 1.4 to the power of x. So this equation here is referring to the equation above. So we've put dollar signs in front of the C and in front of the 13 because we want this a to stay consistent to the power of B5. And then what happens is when you press enter or copy and paste and carry on going down, the equation is able to transform. And this is the way it works. We take this number, which is going to be 1.4. That's why there's dollar signs either side of it. We always want to refer to this 1.4 to the power of the next number down, which is 2. This one here is going to be 1.4 to the next number down to the power of 3. And then we want to see, well, does this look like a straight line? And as before, we are going to analyse Pearson. That's okay, but it's not perfect. You can see that if we put a trend line in here, there would be a clear non-linear pattern. So let's change this number to something else, 1.5, 1.6, 1.7. We want Pearson to become 1. You can see that 1.7 is the best fit. So like before, we are going to write down what the slope is, what the intercept is, and as the final step of this, we are going to say that our formula, therefore, is going to be y equals 2 because the slope of this new graph is 2, so we substitute the 2 in for m here. y equals 2 times z is going to be our a value, which is here 1.7 to the power of x, because this is a growth graph, and plus c. C is such a small value, we're not going to include it. So that is going to be our overall formula.